fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind.
Space exploration is the future, but in order to get to space, we need rockets. Right now, companies are making rockets that cost upwards of $100 million. Even though these rockets are very efficient at times and bring many successes, there also comes many failures that we just cannot afford. So, how can we make rockets that are cheaper and just as efficient? Companies like SpaceX are already developing reusable rockets in order to save the fuel and use the design again. But, what are some other ways? My group and I discovered if you drop an engine mid-air and a plane can catch it, this will save the engine and save the fuel left over in it. ULA will test this in 2021. Another way is to re-enter the rocket on its x-axis to reduce the fuel and the force on the rocket, so you can reuse the rocket and the leftover fuel inside of it. Lastly, find cheaper ways and cheaper materials to make the rocket parts such as titanium and 3D printing. Now I will hand it off to my groupmate Noah, who will present his model rocket.
For our titanium model, we use any can that contained an aluminum exterior in order to represent the present-day rockets. The can we used was also half full to imitate the weight of the interior of the rocket, such as the oxidizer, pumps, nozzle, fuel, and the other various systems that control the projectile. We also covered the can with aluminum foil to simulate the outer layer that protects the rocket from the conditions that outer space offers, such as extreme temperatures and asteroids. The fins of the rocket are made up of cardboard also covered in aluminum foil, in order to maintain the stability and orientation when in flight. As for the nose cone, we use a very thick stock paper to modulate the flow, so that it will minimize the aerodynamic drag and slow down the rocket's speed when launched.
Now let's make Noah's model into a real life-size rocket using Onshape. Let me show you what it consists of. First up is the booster, stage 1, 2, and 3, to get us out of the atmosphere fast and efficiently. Second is the casing, which primarily holds the rocket together. Third is the throttle, which consists of the engine and has the rocket flow in one pace and in one direction. Lastly, the O2 tank will help the rocket fall back on its x-axis during re-entrance. Now I put the life-size model into a simulator to see how it would exhibit against real-life forces and other rocket circumstances. This rocket cost us about $60 million, which is good considering that it's $40 million less than the actual rocket price. Our rocket is phenomenal. Here are some stats of the 150-mile launch. Now, what rocket does this compare to? The Starship SN8, which also falls back on its x-axis and is made of the same material. The Starship rocket is considered to be one of the best rockets ever built, meaning our rocket is somewhere up there.
Main gear. Landing gear now down and locked.
Now you have learned that in order to go to space, we need to reduce the price of rockets.
Main gear touchdown. Pilot Jim Dutton now deploying the drag chute.
Thank you for watching.